my name is Betsy Harper, and I am the owner of this beautiful house at 60 Stern Street, which I very much envisioned as a passive house as a first starting base, because I'm very interested in the whole progression, moving that forward in its market transformation. But secondly, I wanted to do something that no one had done before, and that was use a very unusual architecture for passive house. Pretty complex form, has 3 bays and a huge gable in front, very complicated roof line, and each of those connections between those vertical and horizontal panels are places for thermal bridging, air infiltration, and therefore it was an audacious goal to create something that was Victorian, but that I felt strongly should fit into the neighborhood, should fit into the historical context. So in fact, one of the things that I decided to do was to buy some insurance, if you will, because we didn't know whether we could really build tightly enough for passive house standards, wall assemblies and roof assemblies that would meet the passive house metrics. So the insurance I bought was to have the house panelized in a factory. EcoCore up in Maine created 90 panels and worked extensively with my architect to make sure those were made to exacting standards. They installed high quality triple pane tilt and turn windows made in Poland, as well as the doors. And those panels arrived in 5 installments. Over the course of just 10 days, we were able to put up the entire shell in 10 days. And I'll let Tagore talk about the success of what we created, because it was far beyond our dreams that we could create an extremely tight shell with this architecture and with the complications of the form of this house. So thank you, and I'll turn it over to Tagore, who is a design build professional, and really the key to the success of making this house work.
My name is Tagore Hernandez from Group Design and Build. I'm the architect and builder for Betsy Harper's 660 Stern Street project. We did not set out to do net zero and passive house in the beginning. We were initially interested in pursuing passive house standards, but by virtue of building passive house, we required very little additional solar array to get to net zero. In fact, we're net positive. This particular project had some complex geometries that made the passive house air sealing quite challenging. That being said, prefab was also a complicated feature. Just the sheer number of panels and the general conditions on the site. We had some 14-pitch geometries, which created a lot of very acute angles. We have a number of bays and bump outs that, unlike a lot of passive houses today, just had a lot of challenges in addressing so that we would be able to hit a blower door. One of the other challenges to meeting passive house standard was building a watertight basement, finished basement, underneath a water table. So a lot of passive houses don't have finished basements, but this is one of the requirements for this project. So being able to create, to connect basically vapor closed with vapor open assemblies was a very interesting challenge for us. This project is the first time that GDB has used prefab. We worked with Chris Corson over at EcoCore. This was really the vision of the client, who was very interested in pursuing passive house through prefab. In fact, the owner had 2 simultaneous challenges. She wanted to demonstrate that passive house could be built using traditional architecture like Victorian typology, while demonstrating that prefab doesn't have to be boxes, but could also be, organic and complex geometries that you see in Victorian architecture. The main challenges as far as passive house was concerned was meeting the cooling demands. So we used the porch and overhangs of the building in order to get as much passive shading as possible. The way we used Victorian architecture was we rotated the shape of the building and put the gable facing the side so that we would have a almost due south facing roof system in order to capture as much solar gain as possible. Indoor air quality is improved is with the use of an energy recovery ventilation system that delivers fresh air to all of the living spaces, such as living and dining, bedrooms, and then returns with spaces out of bathrooms and anywhere where there's moisture. For this project, we use a Q450 Zender. We were interested in the fact that it offered some automated and wireless options as far as connecting to your phone, the CO2 internal sensor, as well as the AI, which purportedly learns from its users and begins to self-regulate over the course of time. It comes with standard MERV 8, but we installed MERV 13 filters, and so far we're pretty happy with it. As is a common problem with a lot of builders right now, one of the challenges we had with Passive House was finding a system that's small enough to meet, and rather not exceed, the heating and cooling loads. And we weren't able to really find a ducted system or ductless system to really meet the heating and cooling demands. So we ultimately decided to go with a ductless system to meet some other pressing issues, because a lot of clients are very interested in having zones, as many zones as possible, and this Mitsubishi series allowed us to have effectively 9 zones throughout the building, allowing users to have as many different kind of micro temperatures throughout the building to meet as many different thermal comfort needs as possible. We were also interested in using the ductless system that was in the ceiling and not the more common wall-mounted units in order to meet a more aesthetically pleasing design requirement. In order to meet Passive House certification, we're supposed to meet Indoor Air Plus as well as the EPA water sense. So what we did was we ran a lot of low voltage wiring through the building and connected our ERV boost buttons to an upper doorbell, and then we connected all the low voltage wiring to a recirc pump, which is user actuated with a lower doorbell button. That way it was very intuitive and straightforward for people to come in and either boost for a shower or bathroom use, or conversely run the recirc line in order to make sure that they weren't consuming any excess water before taking a shower. This is an all-electric home, and one of the really heavy hitters in an all-electric building is the water heater. So we decided to go with a hybrid system that generated the most COP with the least amount of electrical load. To my left is the recirc pump. We use a demand control system, which is a user actuated. There's a motherboard over on the left that connects to all the low voltage buttons that we showed earlier. And as per the EPA water sense requirement, we have all of the water lines, all the hot water lines insulated. Similar to the HVAC system, being able to connect to the iPhone and to be able to control it remotely is the ability for users to be able to monitor and control the electrical circuits themselves. So the owner specified that we use a Leviton box that had all GFCI monitoring circuit breakers that can effectively monitor each and every circuit. So it's not just the whole building, but we can actually model and track every single circuit, from the fridge to the solar to the car charger to just general lighting.
As we walk up into the second floor, this is one of my favorite spaces. Very, very tall ceiling, a tremendous amount of beauty just in the natural wood that we were able to bring in the shiplap from the outside. And the fact that we had the big gable in the front enabled us to create this beautiful space and not have it affect the Passive House design requirements at all. So you have a feeling of air and lightness, and one of the major themes of this house is really to try to bring as much nature and light into the building as we possibly can, without, in this case, because it's the north side, not having to shade that and therefore not interfering with the design of the facade at the front of the building, which is so important from the street.
One of the main challenges, I think, with prefab buildings is both for the builder and the architect. The architect has to anticipate and front-load substantial amount of design solutions, which are not common in the architecture practice. Basically, when you prefab, you commit to an entire building. And while there could be certain finishes and walls that get added onto, or minor finishes, mechanical, electrical, plumbing, HVAC, fenestration, so many things that generally evolve throughout a construction process have to be known up front. So the onus is on both the architect, but as well as the builder, to really understand what they're building, because winging installing 90 panels for the first time is going to create a lot of problems for people. Some of the advantages of prefab, and in our case prefab passive, are the simplified air sealing techniques, because they're very discrete and limited to panels, as opposed to trying to track an entire envelope. The other is the level of precision that comes along with a factory-built object, similar to the automation and automobile, or some of the other industries that use prefab as a standard building process. The other was the leapfrogging of construction time. Prefab, we were able to prefab this, or we were able to assemble this building in 10 days, which apples to apples cycle would have taken approximately 90 days.
One of the really nice benefits of having started with Passive House that ultimately was so tight and having an ACH of 0.237 was that we were able not only to get to net zero, but that we are creating more energy than the house will need via our solar system on the outside. And that's even taking into account that we have a charging station for EV vehicles out under the carport. So it's very important that this house, the house owners can be living completely off electricity and actually have electricity extra that they can either sell or donate as they